gotta give her a special shout out.
This is for Manveer. All right. Math 3, Unit 3, Section 4, last example G. First of all, we know this is a degree 4. And my leading coefficient is -1. Based on that information, we know that our right end behavior will go to -infinity because my leading coefficient is negative. And my left end behavior is also -infinity. Okay, why is that? Even degree. Even degrees have to go in the same direction. Odd degrees go in opposite directions. Okay, so next we're going to factor. What can I factor out? Very good. And specifically, we're going to factor out a -x squared. So we take out a -x squared, and when I divide each of these by -x squared, we are left with a positive x squared plus 7x plus 12. Okay, since this is 3 terms, it's a trinomial. We need to factor further. And so we have our multiplication and our adding number. Looking at this, my multiplication number is 12. My adding number is 7. So if we go through the list of numbers, we have 1 and 12, we have 2 and 6, we have 3 and 4. So 3 and 4, both of those add to be 7, multiply to be 12. I don't have to worry about negatives. We're going to go ahead and use the shortcut. Okay, and so we have -x squared, and when these factor, I make my 2 parentheses. Since it's x squared in the front, we know each of these fronts are going to be split up. You're sharing them. So we cut those in half, and each of them get an x. Okay? You can also think about it as this term, but if you have an x squared, each of these go to x and x. Okay? It's like you're splitting them up. Because x squared is really x times x, so you're just splitting them up, you're sharing them. When you have x to the 4th, you're splitting them up as x squared and x squared, okay? Because you have 4 of them. And so then we have, thank you, plus 3 and plus 4.
Wait, then why didn't we split up 7 and 12 like we did with the x squared?
So it's just a shortcut. We can go through the whole long process of grouping, okay? But the shortcut is that the first term here is split up. The last term is what's being split up, the 3 and the 4. And if you were to distribute this whole thing out, you would end up getting back to your x squared plus 7x plus 12. Okay, we can go through this more later, but let's just go through the process of graphing, okay? And so I still have h of x equals, and we have all that, okay? So next we're going to set each of our factors equal to 0. And we know this first one, anytime we have an x in front, whether it's x squared, x cubed, x, that x will equal 0, right? And is it going to be a pass or a bounce? Bounce. And why is it a bounce?
Oh, because the exponent, right?
Good. We have an even degree. Okay, multiplicity of 2. X plus 3 equals 0. We'll make x equals -3, and will that be a bounce or a pass through?
Pass.
Good. And that is because it is a even degree.
Oh.
Good. Or no, sorry, odd degree. Oh my goodness. Okay, 1, right? A 1 degree.
Wait, why is it 1?
There's only one x plus 3.
Yeah.
Okay. X plus 4 equals 0. We get x equals -4. And again, that will be a pass or a bounce.
Pass.
Good. Okay, so let's go to mark our equation. So we have 0, which is at a bounce. We have -3, which is a pass. And we have -4, which is a pass. Okay, my right end behavior we know is -infinity. My left end behavior we know is -infinity. And then we're just going to finish this graph off. Do I need to find my y-intercept on here? Nope, because we already have it at 0. Okay, so it passes through. We pass through again. And then you can see there, it bounces. How many x-intercepts are on this graph? 3. How many relative maximums are there? 2 is correct. There is a maximum right here and a maximum right here. So that makes 2. How many minimums? 1. Very good. There's 1 down here. And that's it.